So while you guys look at another one, besides you guys looking at association, you guys want to look at the differences between two type of treatment. Okay, doesn't matter you want to compare between two different drugs or between drugs A with certain type of drugs with the control, which is the untreated, and your positive control. All right. Well, for those who are using qPCR as well, you want to see the expression of gene A over gene B. Okay. So what you guys could do to see the differences is you guys have to observe the differences. What we call here is the significance of differences. Okay, when you want to compare between the two samples, okay, two condition or between the control or the treatment, you want to observe whether the differences is significant or not. You guys have to do this kind of test. Okay, in this instance, in particular, you guys will do the Ttest and ANOVA. Okay, when we're looking at the association, you want to looking at the relationship between factor A and factor B. For example, you guys looking at the effect of the wave in the case of the nest on the turtle nesting. Okay, what are the factors? How much the wave affect the nesting of the landing of the turtle on the beaches for nesting? The way you guys could do is there are two things, there are two types of analysis you guys could do. The first one is the Pearson correlation, or the other one using regression. Okay, I'm going to teach you guys Pearson correlation and then regression. Okay, and then for the differences between the observed parameters between the treatment, for these particular cases, I'm going to teach you guys Ttest on that cell. But there are another type of analysis you guys want to observe whether your sample, the treatment that you doing have differences. Is another one is we call ANOVA. I'm not going to teach you guys how to do ANOVA with that cell. You could do it, but I'm not going to teach you. Okay, but I'm going to teach you guys ANOVA when we're going into SPSS. Okay, so why do we need to do this kind of analysis, especially Ttest? Okay, why do we need to do ANOVA? Okay, does it enough just by looking at the differences based on the average? Okay, so if you're looking at the average, okay, you know the treatment A or treatment B, there is differences in average. Okay, does it enough to tell the scientific community whether the differences in average is important or that it is meaningful? Okay, so to make sure whether your average differences between two treatments, you guys need to make sure that the differences is not happen by chance. It happen by chance. Kita tak mau. Kita tak nak benda ni berlaku secara nasib-nasib. Kita nak data kita, sampel yang kita collect menunjukkan perbezaan yang sebenar pada populasi. Okay, kita tak nak tengok perbezaan tu disebabkan oleh berlaku secara nasib. Okay, sebab itu untuk tujuan itu, for that particular reason, that's why we need to do the significant p-value test, the confidence level test. Okay, kita kena pastikan bahawa sampel kita itu benar-benar mewakili the population of the sampling. Okay, dan kalau kita tidak, anda kata sampel kita berlaku, the sampling happen by chance, okay, and it can happen, still can give a significant confidence level p-value. Okay, what you guys have done, you guys have committed the false positive. Okay, so for that particular reason, in order to avoid the false positive, when you do the statistical analysis, if you do Ttest or ANOVA or even Pearson correlation, you got a confidence level p-value below that very confidence. You guys need to make sure that it is not due to the by chance. Okay, in order to make sure to avoid the false positive in your sampling, in your experimental design, you guys have to do the power analysis. Okay, you need to do the power calculation. It is not the power to calculate the electricity, the charges. It's not that the power indicate power in statistical analysis. It describes how much sample, how many samples do you need to take, you need to collect in order for you to avoid the false positive. False positive is a very common mistake. Okay, it's happened not just ages ago, but it happens until today. Okay, enough with RTK. Okay, in this particular situation, Okay, when I mention here the correlation, using the Pearson correlation to test the association from between factor A and factor B, or you guys could use regression. If you want to observe differences, you guys could use Ttest or ANOVA. Okay, so now I'm going to teach you guys later on when you guys need to use the Ttest, when you guys need to use the ANOVA. All right, the ANOVA, the Ttest, only if you want to compare between two samples. Treatment, for example, treatment A and treatment B only. Okay, or you want to test between negative control and the treatment A. That's it. Okay, the positive control or treatment A, ataupun there's only two comparison you guys only do. Hanya dua sahaja you want to compare. Okay, dua condition ataupun dua treatment sahaja yang kamu boleh observe. Tapi bilangan replicate tak apa banyak. Okay, manakala jikalau kamu nak compare, if you guys want to compare between negative control with treatment A, negative control with treatment B, negative control with treatment C, and then C want to compare with B and C with A, C with positive control, the best statistical approach, not the best, the simplest approach, the rather is to use ANOVA. But when you use the ANOVA, you guys have to make sure you guys have to be very, very cautious. Okay, they have a preset condition in ANOVA to make sure that the analysis is correct. Okay, of course, whether you want to know, of course, when you put the numbers into the software, it will come out, it will give you the numbers. All right, but they will give you, it will show it significant or not, but does it actually represent the whole population? In order to truly represent the whole population, you guys have to make sure that your sample, your collected, the replicates number is enough to fulfill the ANOVA condition, to do the conditions in order for you to do the ANOVA. Okay, that's why every time, sometimes when looking at the certain journal from the old papers and from certain articles from the old paper, you guys would notice that certain paper has been retracted due to they don't have enough replicate when they make the claim. Okay, they claim this is the finding this probably happened in this particular condition, and turn out when the other researchers, when they read the papers, they want to repeat the experiment. Okay, they couldn't get the same result. That's because the particular paper, your papers, for example, that jauhkan, those particular papers have committed the false positive. Okay, they didn't know because they didn't have any exposure at the time. Okay, biological paper banyak yang kena retract. Okay, yang paper lama banyak yang kena retract. Okay, itu even juga dalam bidang medicine, juga dalam bioperubatan, biomedics, biochemistry, lots of papers they have to retract because of the later first the experiment is not repetitive. Okay, but by all means, another researcher take your data. They do the same exact condition, they couldn't find the same finding. All right. And then what happened? They will start making the claim. They publish the paper, said this is our finding. And then and then they discuss your paper, said they find that they're very contradicting finding between the two, between their finding and your finding. Okay, and it's happened. Even doesn't matter in publication. Even if it goes to Nature or Science, okay, even on Cell, very high impact journal, the cream of the creme de la creme, okay, the top of icing on the cake. Okay, this can even there's paper they have the author have to retract. Once they retract it, be careful where people start to question your reputation. Okay, doesn't matter dekat mana-mana sahaja. Okay, that's why you guys have to make sure when you guys do the research, don't avoid, make sure you design your experiment properly. You don't commit any false positive. Okay, sebab apa orang tak tahu, orang fikir you guys probably falsifying the data. Alright, although you guys didn't know. Enough example. Okay, I'm going to teach you guys how to do correlation. And last week I have teach you guys how to find mean, standard deviation, right? And then, okay, just I don't have to repeat this way again, but just for instance, this particular reason, I'm just going to show you guys. Okay. Teach you guys doing a correlation, Pearson correlation. Okay, it's easy. What you guys need to do, use equal function, press equal, and then just type Pearson. And then you guys notice there is this Pearson function here. All right. And then what you need to do, array 1, you need to select comma, and then the second array. Okay, and then close the bracket. All right. So they will give, so just to repeat again. Pearson. In this instance, I'm comparing between the negative control with the treatment A. First array, and then the second array. Array bermaksud kawasan region ataupun cell mana, from which cell to which cell you want to compare it. Okay, array is the arrangement of cell. Okay, kita nak apa ni? Compare melintang ke horizontal based on row or based on column. Okay, depends how you design, how you put your tables. Okay, so the result here is 0.487. Okay, in this instance, we're comparing between the negative control versus treatment A. Okay, so when we do a Pearson correlation, okay, in terms of numbers, when we're looking at the Pearson, when we're looking at the correlation, we want to make sure whether our finding is positive, have a linear relationship, or they have the inverse relationship between the two factors, or it doesn't have any factors at all. Tak ada kaitan langsung antara negative control. Contohnya kita nak compare, ada tak kaitan antara treatment A ataupun treatment B. Okay, can we do? Kita gunakan. Kita akan tengok sama ada sangat perkataan yang linear positif, bermaksud anda kata kalau treatment A meningkat, anda kata treatment A meningkat, treatment B pun akan menunjukkan peningkatan juga. Okay, I think treatment is not the best way. Okay, if you are looking, if I change the symbol here, for example, treatment A, I change to weather. Sorry, I'm looking at number of nesting total and then compare with the wave height. Contohnya, this particular reason. Okay, sebab kita nak tengok correlation. Kita kaitan antara dua factors. Okay, dua faktor. Nesting penyu dengan ketinggian ombak. Okay, untuk dia punya landing. Okay. So when we're looking at here, for example, now I'm comparing with this nesting negative with the nesting, and then this instance I'm going to repeat again. Pearson, type Pearson, tekan type for the shortcut so to autocomplete. Now I'm comparing nesting with the wave height. Okay, tak kisah mana dulu yang kamu pilih. Kamu nak letak wave height dulu ataupun nesting kemudian as your second array pun tak apa. Either one, okay. In this instance, I have 0, negative 0.02. In Pearson correlation, okay, the highest number is 1. Okay. The lowest number is negative 1. Alright, Pearson correlation. So what does it mean by negative 1, 0, and 1? Okay, if the numbers, for example, like this particular, in this instance, I'm comparing with the nesting versus wave height. Okay, so in this instance, one indicate any numbers that close to 1 is considered have a very linear positive correlation, strong relationship, correlation. Okay, bermaksud, what does it mean? Anda kata makin banyak penyu tu, kalau anda kata nombor tu kat sini makin dekat 1, bermaksud contoh di sini, anda kata nombor tu nilai dia dekat dengan 1, bermaksud makin tinggi ombak, makin banyak penyu mendarat. Okay, bertelur. Okay, walaupun tak ada, itu contoh sahaja. Okay, contoh. Alright, indicate there's a strong linear. Anda kata the numbers, for example, like this one is negatives. Okay, in this instance, it has a very strong inverse correlation. Okay, ataupun inverse relationship. What happened here is, kalau kita contoh di sini, kita the numbers, if you compare between nesting and wave height, you found that the number is closer to negative 1. It indicate that the makin tinggi makin tinggi ombak tersebut, makin rendah penyu bertelur. Okay, the lower the number of turtle that going to nest on the beaches. If the height of the waist increasing. Okay. All right. So 0, what does it mean? 0 indicate there is no association or there is no relationship or there is no correlation at all.
Cuba lah doktor.
Boleh, tak salah. Dipersilakan.
Kalau moderate, maybe negatif 0.5?
Negatif 0.5.
5.
Okey, ya betul. Untuk moderate, kita akan letak negatif 0.5. Terima kasih Amira Nabila. Okay. So, moderate inverse correlation.
Doktor,
Yes, saya.
saya punya 0.0 hingga 0.19.
0.0 hingga ke
0.19.
sebentar, 0.0 hingga ke 0.19. At one point, when you see the values, it shows the values from the Pearson correlation. Okay, the symbol for Pearson is R. Okay, it's a small r. That's a symbol. Okay, so weak linear, anything below, for example, like 0.1, 0.2, that is the weak inverse. Okay, so Afifah, untuk moderate linear,
0.3.
0.3. Now, actually, 0.3 I would consider close to weak, but the one that I would call moderate is 0.5. Surrounding between 0.4, 0.5, 0.6, that is considered as a moderate linear. Okay? Moderate positive linear correlation. Okay? Just a moderate linear. All right? Okay, for Afnan, anything as I mentioned, like between the range between 0.1 close to 0.4 ataupun 0.3. Okay, that is considered as a weak inverse. Okay, tak ada. Terima kasih yang mencuba. Okay, now sekarang ni kita tengok. In this particular example, we have 0.487 blah 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 negative 3. What do you guys think? Okay. Aina Fatin, Hassan, what do you think? Dengan 0.48 ni. Okay. Is it linear strong correlation? Is it moderate linear? Is it weak linear? Does it no correlation ke apa ke? What does it mean?
I would say moderate linear.
Yes, it is a moderate linear correlation. Very good. Okay, thank you, Aina. All right, 0.48 is indicate a very linear, indicate a moderate linear relationship or moderate positive correlation between negative and the treatment A. Okay, these are not the best example. When you do the correlation is one to observe two factors then. Okay, bukan between two treatment. Okay, tak ada kaitan, kamu jangan guna. Okay, sebab apa? There is a paper, you guys could abuse the statistical analysis. Trust me, you guys could abuse. There are papers when they just want to show the abuse of statistical analysis, especially in terms of correlation. Okay, diorang nak kaji, diorang kaitkan dengan kesan cuaca dengan aktiviti lanon. Okay, what they find here is, of course, memang dia tunjuk there is a strong correlation, makin tinggi ribut, makin banyak aktiviti lanon, tapi tak logik. It will give a very high correlation. Make sure that when you want to use, you have to design the two factors properly. I mean, your design experiment, okay? Do not abuse the statistical analysis. Okay, there are certain conditions you guys have to think your logic, doesn't make sense or not. Okay? It's just a software, it's just a mathematical equation, just an algorithm to do the analysis. But then again, it's up to you to decide. Okay, that's why we have a peer review. Okay, now you guys have done I've teach you guys how to do the Pearson correlation using Excel. I'm going to move forward how to do the regression. Okay, All right. How to do the regression in Microsoft Excel? In order for you to do regression, okay, you guys, for the Microsoft Excel, you guys have to use the dot plot. Okay, for example, I want to compare between these two parameters, two conditions, two observed factors, nesting, and wave height. In order for me to do that, I have to go for generate graph, go for this one, for example. All right. And you guys, of course, these are not the correct title. You guys have to change the title later on. Okay, if you want to see here, this will be your x-axis and this will be in your y-axis. Okay, if we select on the dot here, you guys notice which one go to which axis. Okay, in this instance, we have the 14, just 14, these are your x-axis. So the x-axis is your nesting and the y-axis is your wave height. Okay, in this particular instance, in order for you to observe the relationship between these two factors using regression, you guys double click. Okay, tekan right click and then using add trend line. Now you have this trend line. Nampak tak sini display R squared value on chart. And these are your regression values. Okay, pergi tekan kat dot, go for add trend line. Okay, and then go further. Okay, just all right, and then display R squared. All right, these are for the R squared indicate the regression. Okay, in this instance, the regression is signed by the symbol for the official symbol. Jangan buat symbol sendiri. The official symbol for the R for the regression is R squared. Okay, jangan tiba-tiba terasa nak buat simbol sendiri. Okay, tak boleh. Alright, it's R squared. Okay, same cases here. Knowing this number, okay, these are not the way, but these are. Just gonna give me a few seconds to edit this table to make it sense for you. Number of system. Okay, for example. Okay, berbeza dengan correlation, Pearson correlation, the minimum value, the lowest value is negative 1, while the highest is 0, is 1. Okay, is 1, while no association is 0. For the R squared, what do you guys think? Okay, remember the R squared, anything numbers that has been squared, there is no negative values. Okay, the highest values would be 1, maximum 1, the lowest is 0. Okay, so how do you know whether your graph is inverse, positive, or there is no association at all? Okay, which one is weak linear or which one is weak inverse? How are you guys going to know that? Okay, and now I'm going to pick the name as well. Okay, the highest indicate high correlation, while the lowest indicate there is no correlation. Okay, the highest value is 1, the lowest is 0. So if the numbers indicate moderate, okay, how do you want to know whether it is moderate, weak, okay, whether it is inverse or linear? Okay, I repeat. Alright? Untuk kita tengok correlation between the two factors, besides using correlation, you also could use regression. Okay, so what does it mean here is when you do the regressions, the numbers that came out for your regression is between 0 and 1. Okay, 0 and 1. So what does it mean? 0 indicate there is no correlation between, for example, wave height and number of turtle nesting. While if the numbers R squared is 1 or closer to 1, it indicates it has very strong correlation. So what does it mean here is, makin tinggi ombak tu, makin banyak penyu mendarat untuk bertelur. Okay, so indicate there is a very strong relationship. Okay, so what does it mean here? So in this instance, okay, how do I know if the numbers is not 0, somewhere around between 0 and 1? For example, in this instance, I want you to give the numbers that indicate the numbers for the R squared that indicate you have a weak inverse correlation, weak linear correlation, moderate linear, or moderate inverse. Okay? Okay, either one. Siapa nak ambil dulu? Amirul?
Okay.
So,
Doctor,
ya saya.
for week inverse, negative 0.1.
Amira, untuk regression tak ada negatif ya. Okay, tapi it's actually 0.1 is considered as a weak inverse. Okay, tapi thank you.
Based on the graph juga, Doktor.
Yes, sebab tu kita kena ada graf tengok dia punya condong macam mana. Okay, like tu condong macam mana saya tunjuk. Okay, macam mana inverse. Okay, it's actually manakala untuk regression, doesn't matter whether it's linear, whether it's a positive, I think much better, positive or negative, correlation. Okay, the 0.1 stays away. So the answer is whether same goes for linear as well, whether it's a positive, linear or inverse, it is 0.5 as well. Okay, so how do you know whether your graph, whether your factors is positive, whether it's positive correlation or negative correlation? Through regression. Okay, the only way to do is by looking at your graph. Nampak the line here indicate whether it's positive or negative. All right. If I change this graph, because these are indicate 0.005. So what does it mean here? Is indicates is almost don't have any association or there is no correlation at all. All right. So in this instance, is R squared equals close to 0, indicate there is no association. If they have a very strong correlation, okay, if I change this the same exact values, in this instance, I'm just going to do this and paste. You guys would notice the R squared change to 1, indicate they have a very strong correlation. Okay, so and then looking at this graph, is it facing up north to the northeast? Katas indicate it has a very strong positive correlation. All right, macam tadi close to. If they are facing this way, all right, if I do the best way indicate that it has an inverse correlation is the point the line is facing this direction. It's indicate it has a very inverse correlation. All right. So what happened here is kalau dia dapat nombor yang sama, indicates very positive. In this instance, 0.0281. Okay, not the best example. My apology. All right. But then again, kalau facing this direction, in this instance, if close to 1, indicate it has a very strong negative correlation. Okay, that's how you do regression. That's only one. I'm changing this back to treatment A, treatment B. Okay, just gonna put this thing back. For today, I'm going to teach you guys how to do Ttest. Instead, there are so many types of Ttest. All right, there is a student Ttest, a Welsh Ttest. Today, I'm going to teach you guys how to use the student Ttest. Okay, for Ttest, what you need to do is tekan sama dengan type T dot test. Okay, for those who are using the latest 365, the function is T dot test. Okay. Now, for those who are using the older version, you just type Ttest without dot in the middle. Okay, now I'm going to compare between the negative control, the first array, I'm going to compare with the treatment A, whether it is significant or not. Okay, if you're looking at the function here, I'm going to click this. Okay, the format that you have to use, you need to choose which first array, second array. In this instance, I choose my first array as a negative control. And then I choose my treatment A as my second array. And then I choose the tail. So the tail indicates whether it's a two tail or one tail. Okay. So in this instance, I'm going to choose two tail. Okay. So I type 2. Okay, dua bukan bermaksud negative and treatment A. It indicates the one tail or two tail distribution. In this instance, I'm choosing 2. The reason I'm choosing 2 because I'm comparing two different. Okay, I'm going to tell you guys later on. Kenapa? Two tail or three tail. And now I'm to choose whether it is a paired, whether it is two sample equal variance, whether it is two sample unequal variance, whether it is homoscedastic or heteroscedastic or is it paired. Okay, in this instance, negative and treatment A, they are not paired, but you guys have to know whether it's variant, the difference or not, it's different or not. Okay, for this particular reason, I just choose either. Okay, unequal variance. Kenapa unequal variance? Because if I'm looking, I'm doing the variance analysis. Okay. Tekan sama dengan type variance var. Okay. And then scroll here, close bracket, enter is 1.3. And then the treatment A is 6.8. Okay. In this instance, we have to choose number 3, two sample unequal variance, because this one and this has a different variance. So the numbers they gave here, I choose 3, the numbers is 0.00358. Okay, so what does it mean? So when this depends on what the value here is a p value. Okay, they give you straight away the p value. The Ttest will give you, okay, what p value means? P value indicates your confidence level. Okay, confidence level is important when you do the Ttest, ANOVA, and Pearson correlation. Okay, even ANOVA, there is the term we call adjusted p-value. Okay, because they want to avoid any form of false positive. Okay, you choose p-value as your confidence level. Okay, the confidence level, it is most of the time the researcher would choose p-value less than. If you're reading research article, you guys will notice most of the time they choose 0 less than 0.05, indicate 5% possibility to make mistake. Okay, or they choose even more, p-value less than 0.01. Okay, depends on the type of experiment. Sometimes you have to choose 0.05, or sometimes you have to choose 0.01. Okay, what does it mean is 95%, 5%, 0.05 indicate 5% chances to make a positive type 1 or false positive mistake, or 0.01 chances to make a false positive mistake. Okay, so the smaller you get, the lower the chances for you to commit the false positive mistake in the statistical analysis. Okay, that's what it meant. All right. So 0.03, if you're looking at here, because we want to compare better the observed here. For example, you know the average 3.4 is lower than the average for the treatment A. Okay, because this is a t-test between negative control versus treatment A. Okay. If we compare another, for example, now I'm going to test between treatment A versus treatment B. All right, same cases again. Use Ttest in open bracket. Choose treatment 1 as your first array, treatment 2, treatment B as your second array, two tail, and then type 3. All right. And the p-value for this in particular is 0.001. So what does it mean? All right, does the differences, is it significant or not? Okay, kita buat test of significant. P-value as negative confidence level or test of significant. Okay. So what do you think, Mashita? All right, just 0.01. Is it significant or not?
Meaning that there's any difference between treatment A and treatment B?
Mm-hmm. Is it significant or not? The p-value here indicates 0.02 or 0.19. What does it mean? Does the differences in the mean is significant or not?
Not significant.
Okay, the answer is, all right, the answer is it is significant. The differences between treatment A and treatment B, the differences, the mean is significant. Okay, and that's what it is. Okay, there is significant differences, okay, between the treatment. Kenapa kita kena tahu the treatment is significant or not? Why do we need to know? Why it is important for us to make sure that our differences is significant or not. Kenapa? Okay. For your information, all these correlations, Pearson correlation, regression, Ttest, ANOVA, fall under what we call in statistics parametric analysis. Okay, what we call parametric analysis, we know that our sample fall under normal distribution. All right, so what does it mean, normal distribution? If you look at on the graph here, these indicate this kind of graph called as a normal distribution. All right. In this instance, distribution of pizza delivery time is normally distributed. Okay. Andai kata tak normal, you guys wouldn't see this kind of graph. You guys probably see there's two peaks indicate binomial, or there is a flat line indicate there is no normal distribution at all. Okay, contoh data yang tak normal is, for example, you want to identify male or female. Okay, those are an example. It is not the. Okay, so I can repeat. Those are indicate, for example, male and female. You take survey yes and no. You take any survey, for example, what else? Like survey, for example, daripada suka sampai ke tak suka. Okay, those are contoh-contoh non-parametric. Okay, for the particular reason, you have to use non-parametric analysis. Okay, the one that I show you guys here, the Pearson correlation regression Ttest is a parametric analysis. Okay, so how do we know whether the value is significant or not? Okay, when you do the Ttest or ANOVA, you're looking at the p-value, tengok dekat p-value, and then looking at the set the threshold of your confidence. What is your threshold? In this instance, I set the p-value as less 0.05. Okay? Ataupun depends on type, on condition, you can be more stringent. You choose less than 0.01. Indicate, what does it mean? This one indicate 5% possibility that you're going to probably commit the false positive error. While this one, you become more stringent, is possibility 1% possibility that you probably going to commit a false positive error. Okay, this is what I meant. Okay, so possibility, the likeliness for you not to commit is 95%. Okay, so and then well, this one is 99%. Some of the researcher they go 4.001. It's unlikely, very very rare. Okay. So now you're looking at the t-test here, for example, the t-test indicates 0.0035. Okay, the 0.0035 is lower than 0.05. So the differences between the negative and the treatment A is significant. For the treatment A and treatment B, the p-value is 0.001. If you choose 0.05 as your confidence level, then this finding is significant. Okay? Now I'm going to show you guys the differences that are not significant. Let's have a look. Sama with your positive versus your my treatment A, whether it is significant or not. In this instance, I'm going to do the t-test. All right. Positive control. Ada beza tak? Comma. Second array. You choose 2 and then 2 tail and then unequal stochastic. In this instance, it indicates 0.2. Since the value of confidence I choose is 0 less than 0.05, so the differences, you guys notice, the average mean is different. This is 11.6, 9.6 pun, tetapi they are not significant. So this, the difference in means for positive control and treatment A, 9.6, although there is a differences in mean, but the differences are not significant. They tidak significant. So what happened here is, kenapa ada perbezaan dalam positive control and treatment A is indicate the differences in mean happen by chance. Okay, bukan represent the actual population and do the sampling. Okay, so kalau kita tengok dekat dalam normal distribution ni, okay, tengok dekat dalam normal distribution dekat dalam Chrome yang saya dalam lelaki di saya ni. So what does it mean happen by chance or not? Okay, dalam population, okay, kita ambil contoh manusia, how many population, how many billions of the human population? It's called like 4 billions, close to 5 now. Yeah, probably wrong. Okay, so what happened here is you cannot, it's impossible for you to sample the whole human population. So what you did, you pick sample. Sometimes you pick from this region, from sample population of human from this one, the second from here, the third from here. Or probably the first year, second year, the third year. Or probably first year, second year, the third somewhere along the edges here. If you take more, for example, first, second, third, fourth, 5. Okay, ataupun the whole 5, 1, 2, 3, 4, 5. Okay, so it depends. Of course, when you do the sample, for example, if you take sample from here, and you compare the sample from here, of course, the differences, the mean will be differences will be different. But does it happen by chance or not? Okay, in this system, for example, between positive control and treatment A, ada perbezaan antara mean 11.6 dengan sampel 6, tetapi perbezaan tersebut tidak signifikan. Okay, that's fine. Okay, dia tidak hanya berlaku disebabkan masa sampling kamu tersebut. Okay, it happened by chance. Nasib-nasib dapat perbezaan dari segi mean. Okay, in this system, positive control and treatment A are not significant. Boleh Anis?
Boleh doktor. Maksudnya kan, kalau nilai
tu lebih daripada 0.05 dia tak signifikan lah.
Yes, tak. Macam 0.06 tak signifikan.
Okay. Thank you, Doktor.
Okay, sama-sama. Okay, for your lab report. Okay. Okay, when you should choose? When you should. That is your assignment. And your report lah untuk for the second. Ada soalan tak second ni? If you guys don't have any question, sign up and thank you very much. Okay, make sure that you guys go to my YouTube for revisions and subscribe lah. Itu je lah. Okay, Assalamualaikum. Terima kasih.